All right. Hi, my math 40s. Essentially, I ended the last video in section 4.3, which actually wrapped up the graphing trig function section for chapter 4. I got a pretty nice idea though when I was going over the Desmos stuff here, how to go through some examples with you about how A, B, C, and D affect your graph. So remember, we're matching form. Let me clear these out to start from scratch. I guess just keeping with the spirit of what we did in the last example, I'll use a tangent graph. So C plus A times tangent of B times X minus D. So the first graph will be our parent, and that's going to be y equals tangent x. Okay, and then I know for one period it should be between negative pi over 2 and pi over 2. And then I know that those middle values at negative pi over 4 and pi over 4 should give me -1 and +1 respectively for my y values. Make this even here. I'm gonna put this. Okay, so now this is our parent. Parent graph or function is y equals tangent x. And we've actually graphed for x being between negative pi over 2 and pi over 2, not including the n values. Okay. Now let's see what A does. Let's go ahead and add, we'll put 3 for A. Okay, so for this part, let me make a little table. For our original tangent graph, we had negative pi over 2 to pi over 2 and vertical asymptotes there. You can actually just write that instead of putting undefined if it's more comfortable for you. Okay, and then we had negative pi over 4, 0, and pi over 4 as our middle x values. We got -1, 0, and 1. So for this second graph, A is equal to 3. And we want to see what happens to our y values. Okay. Well, we're still going to have asymptotes at the same n values for x. Okay. But now, notice that at negative pi over 4, instead of being at -1, we've shifted to -3. Okay, so this point here, negative pi over 4, -3. Okay, Note 0, 0 is still at the same place though. And then pi over 4, we're not at pi over 4, 1 anymore. We're at pi over 4, 3. Okay. So what wound up happening? Our parent graph vertically stretched by factor of 3. Okay. Let me save that. What would be different if we had a negative in front instead? The negative essentially flips the graph we just had over the x-axis. Okay. So let me add this in. When a is equal to -3, you'd actually still have the same amplitude. Remember, the amplitude would be the absolute value of this, would be 3. But your parent graph vertically stretch by factor of 3, then reflected across x-axis. Okay, let me save that. Now let me go ahead and clear a bunch of junk here. Okay, now the next graph that I want to go over, we already saw what A does. To your graph. I want to look at C next, because remember, C also influences your Y values. Okay, so let's go back here and change this. We're going to put 3 plus tangent x. Okay, so now our C value is equal to 3. So our Y values, whatever we got for our original tangent function, we're going to be adding 3. So the asymptotes will still be there, same place. Add 3 to -1, get 2. Add 3 to 0, add 3 to 1. Okay, let's double check this. So at -pi/4, we used to have -1. Now we have 2. So from our parent, we shifted up by 3 units. Same here. And hard to see over here, but same here. Okay, so this shifted parent graph up vertically by 3 units. Okay, I'm sure you can guess that if we had to put a negative in front instead, we would have shifted down by 3 units. I actually covered that in my last video, so if you want to see that, go to that one. Let me clear this bottom part. So C is also covered. Now B and D actually affect your horizontal translations, so they affect the input X. Let me write that over here. A, C affect Y values, or the range, and B, D affect X values, the domain. So what I'm going to do, I'm going to start with B. Let's go ahead and use a Y equals tangent 2x. Let me save and then erase this part. Okay, so what's happened here? All right, essentially, okay guys, so actually I decided I'm going to make this into 2 different videos. So the first video is going to cover A and C, which cover range, and the second video is going to cover B and D, which cover domain. So hang tight for that video too.